Starting. And I'm going to share my screen just to take a look at what we're doing today. So today we're on class 8. Our topic is scales. It's the first of 2 classes we're going to be doing scales. I made scales instead of back-to-back Monday, Wednesday. I made it Monday to Monday. And the reason why is a lot of times students have difficulty with scales, and I want to give you the opportunity twice to come into the classroom to work on it. Okay. Hey, Gillian. So we're doing scales today, and then we're going to do scales again next Monday. And if you are having difficulty today or on the homework, then I definitely want to encourage you to come to class next Monday. So we're going to be looking at the ANSI standards at scales. We're going to be working through some of the homework sheets. And I wrote here that I need solutions because as we work through the homework sheets today in class, I'm going to be starting to fill out the solutions. We're going to do it together and we'll post it. And then at the end of class, you will have your second isometric quiz. Okay, so I'm going to stop sharing for a moment. You should have already purchased your engineering scale. If you purchased it through the bookstore, if you bought the kit from the bookstore, then the scale is in there. If you purchased it in class from me, then you have the scale, or maybe you purchased it on your own, but you need to have the scale next Monday. So scales are triangular in shape, and there are many different kinds. There are engineering scales, there are architectural scales, there are metric scales, and then there are combinations. So you need to make sure that you're getting the correct one. You want to get the engineering scale. And on week 0, under required material, it says the engineering scale that you want to get. If you look, let me pin myself for a moment. Can everybody see the scale? See how it says 10 here? And if you rotate it 30, 50, 20, and if you rotate it to the other side, there's 50, 60, and 40. So an engineering scale, there's the 10, 20, 30, 40, 50, and 60. So there's a scale between 10 and 60, and we're going to be talking about that a lot today. And the way you know that an engineering scale, it is triangular in shape, and it's divided up so every one of its sides is between 10 and 60. Now, this is not the most expensive kind. There are ones that are made out of metal. There are ones that are made out of really nice wood. This is probably one of the more expensive plastic ones. It's color coded, but there are cheaper ones that are like this. In fact, usually I have in my purse this one, which is a tiny one. It's only 4 inches long. In your kits, there's another one that's really nice. It's a metal one that looks like this. So this is pretty nice to be carrying around. You know, a 12-inch scale is not really that much fun to be carrying around. But those of you that are going into civil, architectural, environmental, agricultural, or structural will be using this all the time at work. But it's nice to have a smaller one that you could carry around with you. I also have, instead of the 12-inch one, it's the same kind. It's 6 inches. So you need to make sure that you're having an engineering scale by next Monday. And those of you who came in late, I just announced to everybody that today is our first of 2 days doing scales. And instead of doing them on Monday, Wednesday, I have them both happening on Monday because many times students have a difficulty with scales. And I want to give you the opportunity that if you're having trouble with scales today, you could come into the next Monday's class because Monday's the day that we could actually be in class. Okay, so if we go back to our module, you'll notice that today is September 20th. We're doing scales today. We're going to work on some hands-on stuff. We're also going to start working on the homeworks together. And then at the end of the class, you have isometric. And then the following Monday, a week from today, is the second class of scales. And that's when you want to make sure that you have an engineering scale. Okay, so I'm going to stop sharing for a moment. Any questions? I'm going to see who's here now. Okay, Gillian's here, Chris is here, Tony, Adam, Josh. Okay. All right, make sure you change your names. And also, I remember the requirement in the class is for me to either see your face, right, have your camera on, or have a picture of yourself. Okay, so those of you that are out online, please do that. Okay. Okay, so we are going to start looking at scales by looking at something that you're a little bit comfortable with already. And those of you who are here, make sure you get one of each of these sheets up here. So come on up and get this. The sheets that I'm going to be using are posted on the website, but I did print out some for those of you who are here. So I'm going to my presenter, my document camera. And let me pin it. Everybody should be seeing it pretty large. Is that right? And let me turn it so it does. It looks backwards to me, like mirrored. Does it look backwards to you too? It looks correct to you?
It looks correct to us.
How come I see it backwards? Well, I mean, but whatever I see is what you should be seeing, it seems to me.
Your camera's flipped. You can see yourself more clearly.
Yeah, well now, did you see any change at all? No, see, I did. It just flipped it, so now I could read it. Okay. Do you remember in the SOMA project, you had to draw for each of the parts in your SOMA project, you had to draw the multi-views and the isometrics, and you were to draw them to scale. And I introduced to you what 1:1, 1:2, and 1:3 was. So now we're going to take a step back and learn about it in more detail. There are two different types of scale. So again, this sheet is posted on today's module, and everybody here has a copy now. Okay, and can you see all the numbers? Does it look okay? Can you see that this says 1/2 inch? Yeah, that's probably a little bit better for you. Okay, so in this class, we are going to be looking at two different types of scales, the mechanical engineering, ME scale, and the CE scale. Even though this scale, all this row represents a civil engineering scale, it's also called the engineering scale. Now, the terminology is a little weird. The term scale is the tool. This is a scale, right? It's a tool. But the term scale also applies to a scale of a drawing. So we are going to be looking at both the ME and the civil engineering scale. So it's the type of scale. This is the type of scale, and then how a scale is represented. So we use the term scale for too many things. And I think that poses a little bit of confusion. So for now, know that this is the tool and it's called a scale, but we're not talking about the tool right now. There are two different types of scaling a drawing, the ME and the CE. And we're going to talk about the ME first, and then I'm going to do some drawing. Notice for the ME scale, mechanical engineers use inches because they're typically designing smaller parts. Even if you're talking about car parts that you may call larger, it's still relatively small in terms of comparing civil engineering things, which build houses and roads and bridges. So the standard unit of measure for mechanical engineers is inches, and for civil engineering is feet. So what's the standard? Everybody unmute yourself. What's the standard for mechanical? Inches. What's the standard for civil? Feet. Notice civil engineers use decimal feet. We do not use fractions, and we do not use inches. We only use feet. Mechanical engineers are using inches, but they could be represented both in decimal form or in fraction. Is everyone comfortable so far? This is really important. You need to know which unit of measure you're going to be working on. Those of you who are mechanical are going to be using inches. Civil, you're going to be using feet. Okay, the way you represent a scale in mechanical engineering is a scale always has an equal sign in it. You see the equal sign? On the left side of mechanical engineering, it's a fraction of an inch. And then on the right side, it's an inch. In civil engineering, the left side is 1 inch and the right side is so many feet. And notice this X has to be a 1, 2, 3, 4, 5, or 6. Why? Because the tool scale goes from 1 to 6. Everybody good so far? Thumbs up? Can I see some thumbs up? Okay. So a mechanical engineer. So let's look at some examples. And now we're going to stick to just the mechanical part. 1/2 inch is equal to 1 inch. Again, a scale, whenever you use the term scale, we have to have an equal sign in here. So let's look at the first example. 1/2 inch equals 1 inch. And remember, when we deal with the scale, on the left side and the right side of the equal sign, the left side represents the length on paper. And on the right side, it means the true length or the real length. So if I have something that says 1/2 inch on paper equals 1 inch in real, I want to convert that to something that we've used already. There's something called size. So scale and size are kind of synonymous with each other, but scale always has an equal sign and a size has a colon. Do you remember us using 1 to 1, 1 to 2, 1 to 3? When you use a scale, you have to have units of measure on both sides. But in a size, there's no units of measure written on both sides of the colon, because whenever you use a colon, it means that it's the same units on both sides. So whenever you use an equal sign, you have to have the units on both sides. But when you use a colon, you don't need to have units because it's implying it's the same units. The other thing is with size, it's always whole numbers. So let's take an example. If I have 1/2 inch on the left side is equal to 1 inch on the right side, and I'm going to go around again. Let's go from the bottom. Zane. So a scale in mechanical engineering is 1/2 inch. A 1/2 an inch on paper is equal to 1 inch in real. I want to convert it from a scale to a size. So instead of having an equal sign, I'm going to have a colon. And the scale has to have a fraction on the left, but the size is always whole numbers. And notice the left is always a 1. So 1/2 inch is equal to 1 inch is equal to what size? Zane?
1 to 2.
Great. Okay. So that's the first step. So let's back up a little bit. There are two things, either scale or size. Scale for mechanical has a fraction of inch on the left side of the equal sign, has 1 inch on the right side. A size is whole numbers. On the left, it's 1. What I'm trying to do is go from scale to size. They both mean the same thing. Zane, what do you think this means? If we know the standard unit of measure for mechanical engineers is 1 inch, what units do you think are on both sides?
Well, I guess inches, right? Or
Inches, yeah, inches. So I'm going to write it really light because we're not going to write the units. But basically, Doesn't 1/2 inch on the left equal 1 inch? Isn't it the same as 1 to 2? Because what I do is I say 1/2 inch is equal to 1 inch. And what I do is I multiply both sides by 2. This cancels and it comes out to be 1 inch is equal to 2 inches, which I write as a size of 1 to 2. Okay. All right, Jason, what about 1/3 of an inch equals 1 inch?
Would it be 1 to 3?
Yep. Tony, 1 inch is equal to 1 inch. 1 to 1. And 1/4 of an inch is equal to 1 inch, Sonny?
1 to 4.
Yeah. Okay, so now we're going to stop for a minute and I'm going to draw something. Right now, I have this part. Can everybody could see this part, right? And those of you and what I'm going to do is I'm going to draw the front of it. But let's just take a look at the back just to see what it looks like. And I'm going to draw it 1 to 1. And if I'm drawing it, Steve, if I'm drawing it 1 to 1, what does that mean? Exactly the same size. So let's take a look. This is 4.5 inches wide. So my this is 4.5. My width is 4.5 inches wide. My height is 1.4. 1.4. And let's see how far over I'm going. 0.9. So I'm going to go up and I'm going to go in 0.9. That's right here, 2, 4, 6, 8, 9. It goes down. It goes down 4. Set 1.6. 0.6 comes up. Okay, so its height 0.2, 4, 6, 8, 10, 12, 14, 1.4 inches. The width is 4.5. And let's see, we have a hidden line that comes up. 0.45. And there's a hidden line that goes across. Okay, how does my drawing look? Read.
Yeah.
Okay, did I miss anything?
Yeah, you have a hidden line. Another
For
one.
what?
Oh, never mind. You got that.
I got the hidden line, but there's something else here.
There's a hole.
There's a hole. This lines up and the hole is in, so I should have another hidden line here. And it's this wide. And what else? Is there anything? Okay, so Rami, is there anything else missing? What else is missing? This is my front view, just so you could see. Not here. Mark, what else is missing?
The back part of it.
This back cut right here, right? There's got to be a hidden line there and it goes down right from here. Okay, what else is missing? May?
I feel kind of confused by that last hidden line you just put on there. Do you
This
mind
one right here?
further? Yeah. Why is it
Okay,
only going up
so-
halfway?
So see? Oh, no, you're right. Should go up all the way. Great, May. Excellent. Good. Good job. Okay, so what else? Do you see anything? You caught that one. Let's go to the next. Luis? What else is missing? I believe I have all my visible lines drawn. I believe I have all my hidden lines drawn, but there's another line that should be drawn. What's this right
Is it for the hole?
Yeah,
like
a hole.
Center line for the hole?
So I need to have a center line. Okay, so when you look at this, right now, technically it's correct, but can you distinguish the difference between the thick lines and the thin lines? No, so there's a problem here still, right? So I would pick out my Sharpie and I'm gonna go back over. And when I draw it, I tend to draw all the horizontal lines at the same time because my hand is already in the mode of drawing. And then I'll draw the vertical lines because my hand's in that mode. Okay, so my width was 4.5. Question?
Will we be using pen?
I wound up going over it because I have a nice sharp Sharpie here. So I wound up going over it with it because it's thicker.
Okay, so that's it. So I'm having trouble. I'm using the 0.5 and the 0.9, and I feel like they're still the same darkness. So-
Then, well, not darkness. They both
Okay.
should be equally dark. It's just that one should be thick and one should be thin.
yeah, I feel like they're the equal width, but using a
0.5
dark
and
pen,
0.9.
I have 0.9 and 0.5.
Yeah, there should be a difference, but in any event, let me keep going because this is not,
Okay.
we already know this stuff, right? I'm talking about scales. So right now, when I measured this piece, it was 4.5 inches wide and it was 1.4 inches height. And that's what I drew it as. So I could say that this is a scale of 1 inch is equal to 1, or I could say it's a size of 1 to 1. Is everybody comfortable with this? I took the drawing, I took the part and I drew the front view of it and I drew it the dimension that it's at. This is also called full size. So I'm going to go back to here and write down that 1 to 1 is full size. All these terms you need to know. Now, what if I wanted to draw it instead of 1 to 1? Let's say I wanted to draw it 1 to 2. Well, this is written as a size, right? How would I say, Josh, I'm up to you. How would I write the scale of 1 to 2? How would I write it? I know as a mechanical engineer, on the left side, I have to have a fraction, left side of the equal sign, and on the right side of the equal sign, I have to have 1 inch. Josh?
So it'd be a 1/2 inch equals
Yep.
1 inch.
1/2 inch equals 1 inch. And could you describe that to me in words?
For every inch in the real world, a 1/2 inch is used on paper,
Correct.
something along those lines.
Good. Or we could have said the opposite thing, right? Every 1/2 inch on paper is equal to 1 inch in the real world. Josh, you want to try? This is called full size. What is my drawing going to look like? Let me zoom out a little. Is my drawing going to be bigger or smaller?
Your drawing
Here,
should be
1
smaller.
inch on paper represented 1 inch in real. Now it's a 1/2 inch on paper equals 1 inch. Is it going to be is it going to be smaller or larger? Josh?
It should be smaller
Smaller.
on paper.
Right. So instead of being drawn at 4.5 feet, it's going to be drawn at 2. And instead of going up 1.6, it's going to go up 0.7. And then it's going to come over. And instead of coming over, let's see, 1, 2, 3, about 2 Bach, it's going to go up to here. And I'm not going to draw all the hidden lines now. It's going to come over about 2. It's going to come down 1. It's going to go over 1, 2, 3, 4, about 8. It's going to come over about 4. It's going to come up. And it's going to look more like this. Jorge, this is called not full size. What do you think it would be called? Take a guess.
Half size.
Yay, excellent. Half size. So when I'm saying this word half and full, these are adjectives describing the drawing. As the person who is drawing this, I have control of what the size is going to be on my paper. I don't have any control of what it really is. So it's half size means my paper, the drawing on paper is half the size of the real object. How's everyone doing? Good? I'm going slow, just in case. Okay, so now let's take a look back at this sheet. Usually in mechanical engineering, it's 1 on the left side, colon, and then an X. But there are times that something will be like this, 2 to 1. Instead of 1 to 2, it's 2 to 1. Oh, and we learned that this is half size. So, Joel, what is the scale for the 2 to 1? Right, so how do I write it in scale? Yeah, 2 inches equals 1 inch. Okay, so normally a mechanical engineering scale is a fraction of an inch on the left side, but there are times we have something different. So 2 to 1 is also done. And if you want to think of it as a fraction, it's really 2 over 1. If Gillian, if 1 to 1 was called full size and 1 to 2 is called half size, what's 2 to 1 called? Yep. Double size. How is everybody doing? Okay, Derek, what's 1 to 4? Derek? Daniel, what's 1 to 4? Quarter size. So which one of these scales, Colin, which one of these scales has the drawing smaller than the object itself? Colin? I see somebody wrote in the chat. Oh, okay, yeah. Adam gave a suggestion of using a 2 millimeter mechanical pencil, and that gives you a really fine point. I'm gonna get rid of the chat. Okay, Colin, Chris, which sizes produce a drawing that's smaller than the object?
The size where the left number is smaller than the right number.
Good. So this one, and this one, right? Those all are the drawing is smaller than the object. That was Chris, right? Brian?
Yeah, that was me.
Okay, Brian, in terms of civil engineers, do you think civil engineers are drawing things smaller than they really are?
Me?
Brian with the Y.
Okay.
Do you think civil engineers are drawing things that are smaller than they really are?
hmm,
Think about it. A civil engineer
Possibly, yeah.
designs a house. They got to
Yep.
put it on a piece of paper.
Yep.
It's totally going to be way smaller, right?
Yep. By a
So
lot.
in the red, what we noticed is the right side is larger, right? So 1 to 2, 1 to 3, 1 to 4. In fact, let's do some conversions here for civil engineering. If I zoom in, notice on the right side, it's feet. We're really taking something huge and making it way smaller on paper. So let's think about how can we take a 1 inch is equal to 200 feet and convert it to a size. So Berto? Berto?
Yeah.
Here. So remember, with the size, we have a colon, right?
Yeah.
And on the left side, it goes, a 1 is on the left. On the right side is another number, but they have to have the same units on both sides. So here I'm converting from 1 inch to 1, but this is 200 feet. What do I need to do to the feet to get it to be the same units?
Convert feet to inches.
Right, multiply by 12. So this
Yeah.
would be 2,400, is that right?
Yeah.
Yeah, okay. How about Ben? How about converting 1 inch is to 4,000, 1 inch is equal to 4,000 feet. How do I convert it to size?
Multiply it by 12.
Great, what do I get?
That would be 48,000.
Yep. Okay, how about Angel? I don't think Angel is in our class anymore. Right? Alex? No, not you. Oh, maybe. Yeah, Alexander, sorry. Alexander, so 1 inch is equal to 10 feet? Right, 120. And then Adam, 1 inch is equal to 600 feet? Adam,
That would be 7,200
right,
inches.
okay. So wouldn't you also say that, let me get rid of my chat and let me move down so you could see all this. So wouldn't you say that all these were drawing it? The drawing is much smaller than the object, right?
Yeah.
And somebody mentioned that when the left side of the equal sign or the left side of the colon, let's say the left side of the colon is smaller or the right side is larger than the left, then you know you're drawing something smaller. So if I were to draw this picture 2 to 1, how would I draw it? It would be much bigger, right? Right, so let's zoom out on this document camera. Instead of now, it's going to be eight inches out, right? And it's going to go up double. I'm just going to estimate what it's going to be like. This is going to be double size. Okay. So you've done some practical work on this already for your SOMA project, and then also trying to get whatever object you chose for your drawing, the object you had to pick and you wanted to draw it. You probably had to shrink it down, or maybe it fit with one to one. But remember, whenever we do engineering drawings, we always have to make sure that how we're orienting the paper we know that our isometric is always up here, our front view is here, our profile view is here, and the horizontal view is here. So in this case, if I wanted to get all 4 of these things on a piece of paper, and we're back to Zane. Zane, what size is this paper that I'm using? Remember the
A
letters?
size?
Say it again?
A size?
A size, it's 8.5 by 11. Let me pull this out. So if I only have 8.5 by 11, in fact, there's a border on it, right? So I have maybe only 7 inches one way, and maybe I have 10 inches the other way to get everything on. So I have to determine the appropriate scale for my drawing. Everybody good so far? So let's go back to this. So an overview. We are going to be looking at mechanical engineering scales and civil engineering scales in this class. And civil engineering scales often are just called engineering scales. The standard unit of measure for mechanical is inches, for civil it's feet. Mechanical are fine using decimal or fraction, but civils only use decimal. They never use inches. The scale has an equal sign. The size has a colon. For mechanical engineering, typically it's a fraction on the left, 1 inch on the right. For civil, it's 1 inch on the left, some number of feet on the right, but it has to be something that's 1 to 6. Okay, and do everybody understand this? 1 could be 1, it could be 10, it could be 100. And then in converting from scale to size, I have to have the same units of measure on both sides. So when I had 1/2, I multiplied both sides to have by 2 to get a 1 to 2, and then a 1 to 3, a 1 to 1, a 1 to 4, and this stayed a 2 to 1. And whenever I have a larger number on the right, it means I'm taking more length in real and shrinking it down on my paper. And as a draftsperson, I have control of my paper. So when I say it's quarter size, it means the paper is the quarter size of what it is real. Does everybody understand that? Sometimes people get confused about half size and double size. This is the object. Those of you, this is the object right here. If I'm double sizing it, I'm making it bigger on the drawing. If I'm half sizing it, I'm making it smaller. I have control of how I draw it. The object is what it is. You're not double sizing the object from the paper, right? The object is what it is. I have control of the paper. How is everyone? Good? Yeah? Okay. Okay, let's focus this. So now what I'm going to do is, let me take a look. Let me show you the 2 pages we're going to be looking at. So these are the 2 homework sheets. So we're actually working on the homework in class. So the first column says what the scale is, and I want you to tell me what type of scale it is, right? We've seen mechanical engineering scale, and we've seen civil engineering scale, and you could just write ME or CE. But there may be some on here that are not the ME or the CE scale. So I first want you to write down what the type of scale is, and then I want you to write down what the corresponding size is. Okay. And right now it is about 3:15. Yeah, let's just wait and do this. I'm gonna stop recording for a moment. Just resume. And I'm gonna put my pin mine. So Jason, which one is mechanical engineering? Okay, Tony, which one do you see as
2 and 1
mechanical? Oh,
or
say it again.
like the fractions one.
Okay, which one?
The 1/4 equals 1 inch.
Yeah, so this one right here is mechanical engineering. We notice that on the left, it's a fraction of an inch, and on the right side, it's 1 inch. So this is mechanical engineering. And Jason, what is the corresponding size then?
1 is to 4.
1 to 4.
Mhm.
So the way you would say it is 1, 2, 4. So the colon is a TO.
Mhm.
Okay, Tony, you find another one that's mechanical engineering? 2 to 1, right? And you actually said what the size is already, right? 2 to 1. And what else could we call this besides 2 to 1? Double size. And Jason, going back to you, what else could I call this? It's 1 to 4, but in
Quarter size.
quarter size. Okay, Sunny, find a civil engineering one for me.
Civil would be the 1 inch to 200 feet. 1 inch
Yeah.
equals 200 feet.
And what would the size be?
Is it 1 to 2400?
Yep. Typically on civil engineering plans, and I know a number of you, like Jason, you're interested in civil. And I think Jorge, you're interested in civil. And Gillian, you're interested in ag and environmental. And Daniel, you're interested in architectural engineering. And some of you are still not undecided. Those of you that are interested in civil, typically this size is written on aerial photographs. But the regular scale is written on a civil engineering drawing. Okay. Steve, what's another civil engineering scale here?
On the last one,
The last one. And what's the equivalent size?
1 to 720.
Yep. Good. Okay, Reed. And your Reed, I know you're interested in mechanical engineering, at least you were at the beginning of the semester. Why is this not a mechanical engineering scale?
Is that a foot and an inch? Because it goes to?
Yes. It says a foot and an inch here. 1/8 sounds okay. It's a fraction of an inch on the left side, but on the right side, it has a foot and an inch. And Rami, are you here?
Yes.
Okay, why is this not a civil engineering scale? So it's definitely not mechanical engineering because it has the foot here. Why is it not civil engineering? What is the standard way of representing a civil engineering scale? So go back to the sheet.
Let's see.
Civil engineering, what's the standard?
Inches,
1 inch on the
1
left
inch
side
on the left and feet on
and
the
feet
other.
on the right. So, and
Right.
it's 1 inch, it should be a 1 inch on the left and it should have only feet on the right. So it's not a civil engineering scale. Does anybody want to take a guess at what kind of scale it is? It's architectural. It's an architectural scale. And an architectural scale, let me just tell you what it is. It has a fraction of an inch on the left side. And then it has 1 foot 0 inches on the right side. So those of you who are interested in civil or environmental or structural or architectural, you're going to wind up learning how to use an architectural scale. And I teach it in the surveying class. So architectural, Tony, were you the one who said architectural? Could you still convert? What is the size? It still could be converted to a size. Okay, so definitely I want to multiply both sides by 8, right? But the colon means I need to have the same units on both sides. Yeah, you have to do the conversion with the 12 too. So you have to multiply both sides by 8, and then you got to multiply it by 12. So it turns out to be 1 to 96. Is that correct, everybody? Did you get that? So you had to multiply both sides by 8. that drops out the 8. And then you have 8 feet on the right, and you got to multiply it by 12 to get inches. Okay, and Mark, I think I'm up to you. Mark? So what scale is this one right here?
Would be architectural as well.
Architectural as well. And what was the size? What would the size be? 1 to,
1 to 48.
yep. How's everyone feeling? Good? Okay, so it's, Tony, what? It couldn't be. So the standard for an architect scale, it has to have a fraction of an inch on the left, and it has to have 1 foot 0 inches on the right. So Tony asked, well, what if there's 1 foot 3 inches or something? You can't use the scale then. The standard is a fraction of an inch on the left and then 1 foot 0 inches on the right. All right, I think everybody's comfortable so far. Let's see, double size.
Hey,
Use-
Joanne, can you go, can you do how'd you get 96 on the top?
Sure, on the top, yeah. So let me do
Yeah.
the math. So we always want on the size, we always want a 1 here, right? So in order to get a 1, I got to multiply both by an 8. So the 8's drop out here. So now I have 1 inch. Now I have 8 times 1 feet. I have feet, but I got to convert it to inches. So 12 inches over 1 foot. So I have to multiply by 12. So it's 1 to 96. Right, in the civil engineering scale, I had the 1 on the left here next to the left of the colon, but I had to take this and I had to get inches on both sides. So I multiplied this by 12 to get 24 inches. So I had to do the same thing up here with the architecture scale. I had to multiply it by 12 inches. Good? Yeah?
Yeah, I got it. Thank you,
Okay, I don't know whose voice that was. Whose voice was that?
Brian.
Say it again.
Brian.
Brian, thanks, Brian. So you got it now, right? So that's the same thing here with this architecture. I multiply both sides by 4, and now I have 1 inch up. I have now 1 inch is equal to 4 feet, but then I got to multiply it by 12 to get 48. All right, so it's almost 3:30. I think it's a good time for a break. So let's come back at 1:45. So let me write in the chat. Break time. Return at 3:45. Okay, and I'm gonna remove my pen and okay, so I'm gonna pin my page. And now I'm gonna zoom in. And now our second page of the homework, sorry, my copy has a line through it. It's asking you what the type of scale is and either write, I put civil in parentheses because it is a civil engineering scale is just called an engineering scale too. But that's all you need to write is CE or ME. And you are not going to do any that are architectural because we're only going to concentrate on those 2. And then I want you to choose an appropriate scale based on what the appropriate scale is. And for civil engineering, the appropriate scale on the left is 1 inches equals X feet. And X has to be either a 1 or 2, a 3, a 4, a 5, or a 6. So you could say 1 inch is equal to 60 feet. You could say 5,000 feet, but it has to be a 1, 2, 3, 4, 5, or 6. And the scale for mechanical, we know is a fraction of an inch on the left side. And then it's equal to 1 inch on the right side. So I'm giving you 6 different scenarios here. And some of them are more mechanical, some of them are more civil engineering. So the first thing, it says, if you're drawing mechanical, what type of scale you use. So basically you're gonna write the type of scale here, 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 and then what scale, and then what scale are you actually using? Choose which scale you want. And basically what you need to do is figure out a way to be able to get the real length that they're telling you on paper. And we are looking at A size paper. Okay. So I'm going to give you about 15 minutes or so. You're probably going to need a little bit more time. But I would suggest first read it and go through and write down whether it's a CE or a mechanical, CE or ME, and then pick the appropriate scale to actually get it on your piece of paper. And I'm going to pause the. Okay, somebody asked me about the civil engineering scale because the civil engineering scale, the triangular scale, the tool only has 6 sides. We can only go from 1 to 6. So the leading digit, thanks Adam, to the right of the equal sign has to be a 1 to 6, and then all the other digits are 0. So 1 inch is equal to 2 feet, 20 feet, 200 feet, 2,000 feet, or you could do it like any of these. 7, 8, and 9 do not work. The next question I just had is, for number 1, it says, if you're drawing a mechanical pencil on A size paper, what type of scale would you use? And my question was, are we drawing the front, top, and right side and isometric of the mechanical pencil? No, we're only drawing one size. Okay, so look at your mechanical pencil and figure out what scale do I need to use to draw just this mechanical pencil on paper. Your bedroom, you're only drawing the 12 feet by 13 feet. 3, if you're drawing the front view of a mechanical part and the front view is 20 inches by 10 inches. 4, if you're drawing an electrical device whose dimensions is 0.2 inches by 0.3 inches. So yeah, we're not drawing multi-views or isometrics. We're only drawing the exact dimensions that I put on the question. Thanks, Alexander. Okay, so now I'm gonna pause the recording. We're gonna come back now. So let's just go over some of them and then you guys could work on it again. And let me pin myself. Okay, so I'm not quite sure where we are. So let's just start at the top. Adam, so if you're drawing a mechanical pencil on A size paper, what type of scale would you use?
I would use 1 to 1 so that it's
No,
longest
the
side.
type
Oh,
of scale would be an ME or CE?
ME.
ME, great. Okay, number 2, I already said it was a CE. Alexander, number 3, if you're drawing the front view of a mechanical part whose dimensions are 20 inches by 10 inches on A size paper, would it be an ME scale or a CE scale? ME scale. Ben, if you're drawing an electronic device whose dimensions is 0.2 inches by 0.3 inches on A size paper, what type of scale would you use, an ME or CE?
I would use an ME.
ME, right, because it's still something small, right?
Right.
Okay, Berto, number 5, if you're drawing your property 50 feet by 100 feet on A size paper,
How would you
ME
use
or
that?
CE?
How do you see?
CE, right. And then number 6, if you're drawing the city of Santa Cruz, 15,000 feet by 15,000 feet on A size paper, Brian, what would you, civil or mechanical?
Definitely civil.
Civil. Okay, so let's talk about the 2 scales again. The ME scale versus CE scale. Chris, I don't think Chris is here. Colin, how do I represent an ME scale? What a scale means the equal signs. What's on the left? Colin?
I'm here, Joanne.
Oh, who is this speaking?
This is Chris.
Chris. Okay,
Yeah.
Chris. For ME, thank you. ME scale, if I use an equal sign, what goes on the left side of the equal sign?
A fraction.
A fraction of an inch. So,
Yeah.
yeah, so we'll say a fraction of an inch. And then what goes on the right side?
A whole inch, or one, just one.
1 inch. Okay. And then if I wanted to do it in size, it'd be 1 1 colon, whatever it happens to be, right? I could convert it. Okay, and Daniel, you're here. For civil engineering, what is the standard way of writing scales for civil? Right? Right, and X can have a leading digit, thanks Adam, of 1, 2, 3, 4, 5, or 6, right? And then I could convert this to size as well. Okay, so Derek, you're here? I'm not sure if you have audio.
Yep.
You do, good. Okay, so for number 1, if you're drawing, you have a mechanical pencil and you want to draw the mechanical pencil on paper, what scale did you choose, or scale or size did you choose? Derek? Maybe you're having difficulty. So here's a mechanical
Yeah,
pencil,
this one is
right?
the one that I was struggling. This is
So
the
here's
only
a
one.
mechanical pencil. Can I draw that? Does it fit on a piece of paper, on A-size paper?
Yes.
Yeah, so we could just draw it 1 to 1.
Okay.
Right?
I wasn't sure if I wasn't sure if because it's so small you'd want to make it bigger or not, but
Yeah, no, it's okay. It's still pretty good size. In fact, if I wanted, I probably could put 1 to 2, but it's always best to put it as big as you can on the paper. So is everybody okay? Let's just keep it as 1 to 1. And I could have written it as a scale, 1 inch is equal to 1 inch. Right? But I can draw a piece. So if you could fit it on paper, then draw it 1 to 1. Okay, let's do another mechanical one. So Gillian, let's go down to number 3. If you're drawing the front view of a mechanical part whose dimensions is 20 inches by 10 inches. So picture it, 20 inches by 10 inches. Can I get that on a piece of paper? No. So what would you do? What scale would you choose or size would you choose?
I did half an inch. I think that was right. 10 inches.
Yep. So she's choosing this, which is also, let's see. What is this also called if it was a size? 1 to 2. And in verbal words, half size. So let's see if it works. If I had something that was 20 inches by 10 inches, and I'm only going to draw half of it, half size of it is going to be 10 inches by 5 inches. Sure, I could fit it on paper. Okay, right? 10 inches, I still have room on paper because there is a little border on the outside. If I wanted to shrink it down a little bit more, Gillian, what could I have done also?
You want it down to like quarter, or would you do third?
I'd probably do a third. So if we wanted to make it not so big on the paper, we could do 1/3 inch is equal to 1 inch. Okay, I need to check in with, let me check in with everybody. I'm gonna, I also, when I draw something, in addition to just drawing it, I have to dimension it. So I need room around it anyway. So 1/3 is probably better. 1/3. But it's okay. The point is that you're understanding this concept.
I had a question. Does it matter at all? Because like for me, the 1/2 is very clear how it goes into 20 and 10. What if you don't take into account at all that you might get some ugly numbers, right?
Good point. So Gillian's asking, maybe it would be better. Could you all hear Gillian?
No.
No.
We don't have audio.
Oh, there's no audio on their computers sitting here. Okay, so Gillian, asked, jumping from 1/2 to 1/3, and you're gonna get some funky numbers, would it be better to jump down to a quarter or a fifth? Yeah, you can. Quarter's fine, fifths, as long as it's not too tiny. And when you look at it, you're gonna be able to tell if this looks okay or not. Okay? It's not, you don't have to be an expert on drawings to do this.
Right, but you've already drawn it, and then like, okay, that doesn't look right.
Right, it doesn't, right, right,
Find it, you know.
right. And you're gonna find, so Gillian just said, well, I definitely don't want to draw it once and then realize it's too big or too small and then have to redraw it. What you will love is AutoCAD, because you draw everything on AutoCAD full size. And then you tell it how to print it out, what the scale will be. So you don't have to erase things. Yeah, it's pretty nice. Okay, so let's go back and say, okay, yeah, maybe 1/2 is going to be too big. So let's instead, let's just say instead, let's use 1/3 inches equal to 1 inch. So let me just do it in size. I'd do 1 to 3 or 1 to 4. Okay, how are you all doing? Is everybody okay on mechanical? We didn't do the civil yet. I see some thumbs up. If you have questions, you got to ask me because I can't help if I don't know.
Joanne,
Yes, Adam.
I also sent this in the chat, but I've been choosing my scales so that the longest side of the object can fit on the shortest side of the page, so 8.5
Ah.
inches. Is that okay, or would that make the rest of it too small?
It doesn't matter which way. It's going to really depend on how you orient your page, because it's going back to, right now, I'm just trying to figure out if you understand scaling. But in the scheme of things, in the end, when you produce a piece of paper, you're going to have the front, the top, and the right side and the ISO. So you're going to try to fit it right here. It's got to fit here. So you're going to have to determine a different scale. Right now, we're just trying to get it fit on one page. And it doesn't matter whether, if I'm just drawing one thing, it doesn't matter if I draw it in the portrait mode or in the landscape mode. But certainly when I'm drawing the multi-views and the isometric, I'm going to be in the landscape mode.
Okay, thank you.
Okay, thanks. All right, let's go to the next ME one, which is number 4. And I don't know where I am. Gillian, did you just answer a question?
Yeah.
Okay, Joel. For number 4, if you were drawing an electronic device whose dimensions are 0.2 inches by 0.3 inches on A-size paper, what type of scale would you use? So we chose ME. What would be an appropriate scale? Okay, so he wrote 4:1. So let's figure that one out. If it's 4 times as big, what would that, let's see, Jorge, if it was 4 times as big, how big is it going to be on my drawing? The real size is 0.2 inches by 0.3 inches. How big will I have drawn it if I quadruple it? Jorge?
Would it be 0.8 by
Yeah.
1?
Yeah, 0.8 inches by 1.2 inches. That seems still too small. Let me zoom in. 4:1. This part that's really, really tiny is now just a little bit bigger. It seems like it's still too small. So Joel, do you want to pick a different one? Okay, well, let's not do 12 because then we have to multiply by 12. Let's come up. We could do 5. 5 would mean that now if it's 5, it's 1 inches by 1.5 inches. It's still pretty tiny. How about 10? If it's 10, what would it be? It would be 2 inches by 3 inches. That seems a little bit more reasonable. And it even still seems too small. What if we tried 20? 20 times that would be 4 inches by 6 inches. That seems a little bit more reasonable. Is everybody understanding the reasoning what I'm saying? So I probably would do 20:1. You can't. How you would do it is you would write, sorry, it would be 20 inches is equal to 1 inch. I was gonna say no, because it's you, even though ME scale is typically written fractional on the left side, you saw a 2-to-1 and a 4-to-1, right? There is no fractional on the left side. It's a whole number. So you can, and this is how you would write it, but more often than not, you're gonna see it as 20-to-1. You're gonna see it as the size. And even not having, you guys not having experience drawing, does 20-to-1 seem better to you than 20 inches equals 1 inch? I mean, you might not have that understanding or not, but 20-to-1, doesn't that sound like something? And maybe it's because I have all this experience, but I think 20-to-1 sounds reasonable. Where 20 inches equals 1 inch just sounds odd.
You would say 20 pieces going like instead of one.
Right, instead of 1, you're making a 20 size bigger.
Yeah, that makes, I'm just wondering on the, when it asks for scale on like the bottom where. It asks for scale on the bottom, even though you made the point scale is the inches to other inches and the size.
Yeah,
colon,
let me answer that
whether
question.
you can scale these still
Yeah.
in-
So Gillian just asked the question. You just taught us the difference between a scale and a size. And on the homework assignment or on the quiz, the take-home quiz, you asked us to specify a scale. Once you know, and I think you do know now, the difference between scale and size, they're totally interchangeable. So when I say after this class, when I say, what's the scale? You could say 20-to-1. Okay. Okay. So is everybody more comfortable with this, like the 20-to-1? All right. So now, I think I'm up to Josh. Josh, you're here? Yeah. Josh, do you have audio?
Yep. What's up?
Okay. All right. So let's go to the civil engineering scale now. If you are drawing your bedroom, it's 12 feet by 13 feet on A size paper. What would be an appropriate scale? What did you choose?
So let's see, what did I write? See, I don't really know because I chose 1 inch representing 6 feet, or 1 inch equal to 6 feet, but that doesn't really make it neat for the 13 feet, only the 12. So I was kind of lost on this one.
Okay, so I guess at this point, it'd be nice to have everything come out really clean, but things aren't going to come out clean. You just have to choose a scale. So we know for a civil engineering scale, it has to be a 1 inch on the left side, right? So we know it's going to be 1 inches, and we know we have to have it feet on the right. I certainly couldn't put 1 foot, right? Because the 12 feet is going to run right off the page. So what about 2? If 1 inch is equal to 2 feet, how big is this going to be on my paper? Josh, you want to do that? If you pick a scale of 1 inch is equal to 2 feet, how big is this bedroom going to be on your page?
Yeah, so it'd be like 6 inches by 6.5.
Yep. And that seems like a great size to have on the piece of paper. Tony. Good? Everybody good? Now, I could have chose, let's try 1 inch is equal to, what did you say, 6? Let's try 1 inch is equal to 6 feet. Well, then how big
Joanne,
will, yeah?
I actually meant to say 1 inch is equal to 2 feet. I just kind of got my wording mixed up.
Gotcha, because that's where you were talking about the 6 right here.
Yeah, exactly.
Okay, but let's try it anyway. 1 inch is equal to 6 feet. It would turn out to be on paper. How big would it be? 2
So
inches
that-
by 2.5? No,
Yeah.
2 point, what is it, Alexander? 2.23. Anyway, it's too small. Imagine trying to put furniture inside something that's 2 inches by 2 inches, right? All right. Luis.
Yeah.
Okay, number 5, let's do another civil engineering. If you're drawing your property that's 50 feet by 100 feet, what would be the appropriate scale? 1 inch is equal to, how many feet do you want to?
1 to 30.
1 to 30, let's try. So if it's 1 to 30, how big would it turn out to be on paper? 30, 50 divided by 30, it's like less than 2 inches, right? Is that right? So it seems like that might be too small, huh? Does everybody agree? If I'd say 1 inch is equal to 30 feet, I want to get it, here's my paper. And my paper is pinned, right? So you guys are seeing it all? Yeah. I want to get my paper right in the middle. I want it to be this big, right? So I want it to come out about 5, 6 inches. So what should I use instead of Luis? Yeah, let's see, 1 inch is equal to 10 feet. That would be 5 inches by 10 inches, right? Oh, thank you. Thank you. So the property is 50 feet by 100 feet. So let's try 1 inch is equal to 10 feet. It would mean that it would be about 5 inches by 10 inches. That's probably pretty good. It might be that we need to raise it a little bit because 10 inches is not going to give me any room for a border and and dimensioning. So how can we raise it, make it bigger? We can't raise it to 15. What would be the next one up from 10? Luis? We can't do 12 either because it's not on a scale, right? The leading digit has to be a 1 to 6 and all the following digits have to be 0. So when we go up from 10, what's the next thing? What? 20 would be the next. So let's try that. 20 would mean that it would be 2.5 inches by 5 inches. I probably would go to 1 to 10. And I shouldn't say 1 to 10. It's 1 inch is equal to 10 feet. How are you doing? Because the civil engineering scale is a little bit harder, right? Because we're dealing with both inches and feet.
So this one we do have to say, like 1 inch equals 10 feet.
Right. We cannot say 1 to 10 because that would mean that the 1 and the 10 are the same units. We have to say 1 inch is equal to 10 feet. Okay, May. How about number 6? Now we're drawing 15,000 feet by 15,000 feet.
Yeah, so I'm gonna be honest and say that I'm really struggling with the civil engineering.
Okay, good. Thanks for telling me.
Looking at the 15,000 by 15,000, and then I don't know what to do to
Okay.
figure it out. Like from
Okay, and next Monday, when we start learning how to use the scales, the tools, the scales, I'm going to show you kind of a quick way, a trick to do to figure it out. But in the meantime, what we're doing is we're really looking at 15,000 and say, well, I only have 10 inches on my paper. Right? How am I going to get it to be shrunk? So let's go on the back of here. So we had a property of 50 feet by 100 feet, right? So 50 feet, and I'm trying to get it on 8.5 inch by 11 inch paper. This is the property. And I'm trying to get it on this paper, right? And I could actually set up my scale because this is in inches and this is in feet. And I know that it's supposed to be 1 inch is equal to so many feet. So if I take 50 and I divide it by 8.5, could somebody do that? 50 divided by 8.5.
It's about 5.88.
Okay, it comes to 5.88. So if I want to get 50 feet on 8.5 by paper, I could divide the two. But let's think about this. I can't have it like right up to the edge of my paper, right? So let's say this is 7 and this is more like 10. So let's take 50 divided by 7. What does that turn out to be? 7.14. Okay, well, we know this is not an appropriate scale, right? We can't use a 7. So we either have to go down to 6 or we go up to 10. If we go down to 6, remember, the larger the number on the right, the bigger the drawing, right? So I'd have to go up. I'd have to go up to 1 inch is equal to 10 feet to get this on this paper. And then I could do the math the other way too. I could divide the 10, 100 feet by 10, and I'm getting the same thing. 1 inch is equal to 10 feet. So I'm doing it mathematical though. Right now, I'm just showing you how to do it mathematical. I'm taking the real distance and I'm dividing it by the paper to try to get, basically, I'm getting a ratio. I'm getting a fraction. What inches to what feet? And I know I need inches of 1 here. So I'm dividing the 50 by 7 and I get 7 and I have to go up to 10 because there is no 7. And sure enough, that's what we chose. 1 inch is equal to 10 feet. May, does that help?
Very helpful. Thank you.
Okay, good, great. Okay, so then you want to try to do that one this way? So we're looking at 15,000 and I'm trying to put it on 7-inch paper.
So going about the same process.
Yeah. So we have 15,000 feet and I'm trying to get it, let's say, on 7 inches.
Mhm.
So what is this number? Do a calculator. What's 15,000 divided by 7? Is it
That would
2,000?
Yeah. I have 2,142.
2,142.
Yeah.
2,142. So if I come down to 2,000, I'm probably still going to be safe because I still have a little bit more than the 7 foot.
And so that
So
wiggle
what-
room's okay to have?
Yep.
Like, no, okay.
As long as it doesn't wiggle off the page.
Okay. I
So
think
let's-
that's where I get a little
Good.
stuck.
So let's look at this. 1 inch is equal to 2,000 feet. So May, if it's a scale of 1 inch is equal to 2,000 feet, and I'm trying to draw 15,000 feet on my page, how long is this property going to be? 15,000 feet I want to draw on my page. And my scale is 1 inch is equal to 2,000 feet. How many inches?
7.5 inches.
Yep. 7.5 inches. And then
7.5 inches.
7.5 inches.
That
And
seems
it'll fit-
reasonable, yeah?
Yeah, totally.
Thank you.
Does 3,000 work?
3,000, yeah. If we made it 3,000, then I would divide it, would be 5 inches by 5 inches. Yeah, that sounds really good. Yeah, Brian. So is it helpful to think of it in terms of math? I'm trying to get so
Yes,
many
very
feet on
helpful.
so many pages, so much paper. Okay. Okay, now what I find the best is when you're dealing with the ME scale, use a size. Use a size. ME size, ME size. And when you're using civil engineering scale, use the scale, scale, scale. Okay, I know you all have more questions. You have to be brave enough to ask them because I want to make sure that everyone's comfortable. Okay, all right, then I'm going to share my screen. And we're going to go back to the class. And even though I didn't finish, let me move you guys out of the way. We're doing this class right now. Why can't I get it smaller? There it goes. Okay. So the scale reading, I want you to read the scales and then what I would suggest you do, so I'm going to scan all these sheets and I'll post it under the class notes. Oh, I just touched something fast. Hang on. Okay. Okay, I'm on class 8. So what I'm going to do is scan all my class notes and I'm going to post it here along with the video recording. And what I suggest you do is print out the scale homework, print them out blank again, and then do them without looking at mine to make sure that you're comfortable with it. And if you're finding that you're really comfortable, then I'm going to publish the next class, although I didn't finish everything yet. Let me unpublish this, unpublish the quizzes. I'm gonna, when I publish, everything gets published. So let me unpublish this again. Okay, so I'm jumping ahead to a week from today. And don't learn how to use the engineering scale yet, but let's take a look at this homework. So you could jump ahead if you want more practice. Is everybody looking at my homework on the screen? It says for this sheet, change the scales to this and then complete the sheet. Actually, I should say complete. Hang on. Complete sheet. But then there's another page. And this is another, let me just save this. It's another one like this, where I'm saying you want to draw this on this page. You want to draw this on this page. And you could take a look at that. Let me just open it up for you in case you want to jump ahead. Okay, why is there a problem? Let's see if I could, seems like I was able to download it. So what I have here, and this is not your homework yet, it's your homework for next Monday, but if you wanted more practice. So notice, first column, these are all the items, and you're not drawing the multi-views, you're just drawing it. And this put in A size to all of them. Second column is all A size. So I'm telling you that a wrench is 7.8 inches long, and you're drawing it on A size paper. First, are you going to use a CE or an ME scale? And if you use a CE scale, you're going to say 1 inch is equal to so many feet. And the ME, you're going to put 1 to whatever. But you don't need to jump ahead if you don't want to. You might have lots of other work in other classes right now. Okay, but this is part of the homework that you'll be doing. Okay, so I'm going to stop sharing. And actually, it's actually almost 4:30, so it's quiz time.